Good day to everyone. Today we will see how standby generator power connects to the load automatically when grid power is interrupted. Automatic transfer switch panel can be arranged several ways according to the requirements, but here we go for the basics to understand how it works, and then you are free to modify it according to your special needs. First, we have this contactor for the 3-phase 400 volt supply from the grid, and when it is at on position, load is connected with grid power. If we start the standby generator, power will be there up to the L1, L2 and L3 terminals only, since the generator contactor is at off position. If grid power goes off like this, we need to connect the power from generator to the load automatically, and vice versa. To start with, we need two 8-pin timers, one for the grid power, and the other one is for generator power. Further, we require an 8-pin DP/DT relay. DP/DT stands for double pole, double throw. In DP/DT relays and timers, two separate inlet ports are available, each having two outlet points, where one is at normally open position, and the other port is at normally closed position. Then we need two pole MCBs for grid side and generator side. Although I have shown 3-phase power from grid and generator here, you can wire a single-phase 220 volt generator also for the load when grid power is from single-phase 220 volt supply. For this, you can connect phase and neutral wires to any two ports on main contactor and keep the remaining port of the contactor empty. When you take timers and relay out of their bases, you will see the numbered ports like this. On this picture you will see how the positions are numbered for the normally open and normally closed positions, and also the common points and the power supply points. Power connection for the relay or timer is to be given through the points 2 and 7 according to the details given on it. A C or DC power will be connected to these points. 1 and 8 are the double pole input points on it, as indicated by the first two letters of DP/DT, or can be called as common points. 3, 4, and 5, 6 are double throw outlet points of 1 and 8 respectively. Here you can see relay and timer are at off position, since no power connected yet to the points 2 and 7. You will see here, with no power on these, 8, 6 and 1, 3 are at normally open position. Also you will see 8, 5 and 1, 4 are at normally closed position. Further at the top right, there is the clock of the timer, and is set for 5 seconds here. Let's connect phase line to the point 7, and the neutral to the point 2. Relay and timer got power now, and off position changed to on position. Further you will see, normally closed positions on the relay are at open position now, and the normally open positions also changed to closed positions with the power involvement. But on the timer, changes didn't appear yet, and you will see with the power on, clock starts counting, and as soon as it reaches the set time of 5 seconds, the changes happened. This delay time makes sure changeover of these positions does not happen until the restored power is stabilized, and is done as a safety precaution. Let's take phase line to the grid MCB from L1, and neutral wire also from the grid supply. Control circuit here is single phase 220 volt supply. Relay is powered with the supply from the breaker out, connected to the 7 and 2 ports. From number 7, power line is connected to the common point 8 also. Now, relay output from number 6 is connected to the grid timer power supply at number 7. Neutral supply also connected to number 2 of grid timer. This will make sure, as soon as relay is powered, normally open points of 8 and 6 will close, and grid timer 2 gets power simultaneously. Now, connect port 7 to the common port 8, thereby, after the set time delay on grid timer, outlet port 6 gets power. All what we need now is to connect number 6 of grid timer to the grid contactor operating coil A1. On the way, it goes through the normally closed port of generator contactor since interlocking of two contactors need to be done as a safety precaution. Neutral wire need to be connected to the A2 of grid contactor to complete control circuit wiring on grid side. On generator side also, we take phase and neutral wires to the breaker first, and the phase connection now goes to the common port, that is number 1 of the relay. From the relay, normally closed outlet is 4, and we take power to the generator timer from number 4. Neutral wire 2 will be connected to the timer now. Then the power from 7 is connected to the common port 8 of the timer. Generator timer outlet port 6 is normally open, but closes and connects with inlet port 8 after the set time delay on it. Now, port 6 of generator timer is to be connected to the A1 of generator contactor and also will go through the normally closed auxiliary contact of grid power contactor. Thereby, interlocking safety of contactors provided further to the safety provided by timer delay operation. Neutral wire is connected to the A2 of generator contactor to complete the control circuit wiring. Power supply to the load is shown here now, and the control circuit power needs to be kept on by switching on the two breakers. Let's see this condition now. Power supply is not on the load, but grid power is there, up to the contactor top. Issue here is, grid side control power is at off position. Neutral line is kept connected here, for easy understanding. When you switch on the grid side control power breaker, relay gets power, and grid timer 2 gets power, through port 6 of the relay. After set delay time, number 6 gets power, and transfer power to the grid contactor 2, through A1 and A2, thereby supplying 3-phase grid power to the load. On the way to A1, it checks and makes sure that the generator contactor is at off position through interlocking. Now let's see what happens when grid power is interrupted like this. Although automatic transferring of power is available here, generator auto starting is not included and will be discussed in a separate video. So we need to start the generator manually, and 3-phase power will be available at L1, L2, and L3 of generator contactor. Then, the control circuit breaker on the generator side allows power to the number 1 common port on the relay. You will see lines to the port 7 is still on white color, and the relay is not powered yet, but relay output number 4 is at normally close position, and allows power at number 1 of the relay flow to the number 7 and 8 of generator timer. Although relay is powerless yet, generator timer is powered now, and after set delay time on it, number 6 also gets power, thus allowing connection to the A1 of generator contactor. This connection too goes through the normally closed auxiliary contact of grid power contactor to make sure it is at off position. This allows generator contactor to on position, and the load gets 3-phase power through generator now, and will run like this till grid power is restored. When grid power is back, relay gets power through number 7 port, and the 1 and 4, normally closed connection, opens up now. It will stop power to the generator timer now. When generator timer is without power, A1 of generator contactor does not get power, and stops generator power to the load. At the same time, since relay is with power now, number 6 port gets power, through common port 8. This will allow power to the grid timer, and after set delay time, number 6 port allows power to A1 of grid contactor, and thereby 3-phase power to the load through grid power. Only thing we need to do now is to go and stop the generator manually, since generator auto start and auto stop connections are not included here. Hope you got fair idea now how the generator is automatically loaded when grid power is interrupted, and also how power is automatically switched back to grid power when grid power is restored. If this video is helpful, please subscribe to the channel. Thank you.